Good morning, folks. It is Tuesday morning down here in the office. Hope you're all doing well. I'm doing fine. Thank you for asking. Um, yeah, and I am here today to give just a few highlights to kind of continue on from um, the activity you looked at yesterday, where I kind of did a bunch of activities or demonstrations with those carts. Um, yeah, so we're going to talk a little bit about this concept of momentum, and we're going to talk about the concept of impulse, and we're going to talk about how those concepts help us to analyze certain types of collisions, um, because a lot of the interactions that we see in the real world involve some type of collision. So an understanding of momentum and impulse can really help us to understand a lot of those interactions. Okay, so so first to begin, as is often the case um, with sort of like vocabulary words in math and physics, momentum is one of those words that gets used even outside of a sort of strict scientific context. So, for example, it's been a while since there's been any sports on, but if two teams are competing against each other and one team is really kind of starting to starting to pull away from the other team, what you might say is, wow, this team really has all the momentum, right? And I think that concept, the concept that one team is sort of harder to stop than the other, um, I mean, yeah, it's related to the physics definition of momentum, but let's actually talk about what that physics definition is. So, um, one way, sort of using different words to describe what momentum is, and maybe I'll even write this down if I can find my marker. Let's make this a little closer. Okay. So we could say that, does this work? Yes. Momentum is, let's see, mass in motion. Okay. So, everything that we see, well, not everything, photons don't have mass, but, all these objects that we interact with in the world have some kind of mass. As soon as you put them into motion, all of a sudden now this object has momentum. So you have to have mass to have momentum, and you have to be moving to have momentum. So for example, that marker that I just put there has zero momentum because it is not moving, as far as I can tell. Okay, so um, so there's a symbol for momentum. Unfortunately, M is already taken because M stands for mass. So we have to come up with a different symbol for it. The symbol that has been chosen by the scientific community is a lowercase p. So lowercase p is the symbol for momentum. And quite literally, when we say it's mass in motion, the way we compute or determine the quantity of momentum that something has, well, we simply take its mass and we multiply it by its velocity. There you go. A quick check of what are the units of momentum? Well, the units of mass. The standard unit of mass here is kilograms. The standard unit of velocity is meters per second. And so I guess what that means is the unit of momentum is kilogram meters per second. Okay. Sometimes, like with the Newton, for example, a Newton is a kilogram meter per second squared because it's mass times acceleration. Um, this doesn't have a like. This is it. This is the units are kind of funky for momentum. It just is what it is. There's no special name for the unit of momentum, I guess, is what I'm saying. Okay. All right. Something else to notice here, since one of the factors here in the quantity for momentum is velocity, and velocity, if you recall, is a vector quantity, meaning that it doesn't just have a magnitude, but it also has a direction. So since velocity is one of the the factors here, momentum is also a vector quantity. Momentum is a vector, which means it can be positive or negative, okay, depending on the direction of the velocity, the relative direction of the velocity. And that's important when we talk about collisions because, if you have two, whatever objects moving towards each other, one has positive momentum, one has negative momentum, you can see what might happen with those momentums. In a sense, they kind of cancel out because one is positive, one is negative. Okay, I think you got it. All right. I think that is it for momentum. And actually, that's a good segue when I just mentioned when two objects are coming at each other, they collide. There's like an event, and something happens. And what happens as a result is the momentums of those two objects can change. So momentum can change. Okay, and I might want to erase here. Okay, so momentum can change. But it can't just change sort of out of the blue. Something needs to happen. In order for momentum of an object to change, if velocity changes, or I suppose if the mass changes too, right? But most of the situations we're going to look at involve momentum changes as a result of velocity changes, okay? Now, change in momentum, again, that triangle symbol represents the notion of change, right? Change in momentum occurs if there is an impulse. Okay, another word that gets used in non-science contexts, but here impulse has a very specific meaning. We'll talk about that in just a second. A change in momentum is literally caused by some kind of impulse. And what the impulse is can be found if we go back and think about Newton's second law. Okay, so Newton's second law, if you remember, is that one that's expressed typically as an equation, F equals ma, force equals mass times acceleration. Okay, or alternately, since acceleration is change in velocity over time, we could also represent Newton's second law as F equals mass times delta V over T. Okay? All right. I wasn't very careful with how I used the board here, so I'm going to have to erase again and start over because I'm out of space. So this is where so you've got F equals mass times change in velocity over time. That's where I'm going to pick things up here. Okay, F equals mass times delta V over T. Okay, what I'm going to do is I'm going to do a quick little algebra move. I'm going to multiply both sides of this by time. So I'm going to multiply this by time, multiply this by time. And what you get when you kind of clean up the right-hand side is you have F times T equals mass times change in velocity. Okay? And if you think about what this means, what this says is mass times velocity is momentum. Okay? Mass times change in velocity is change in momentum. So quite literally what we've got, and this is just by doing a real kind of simple trick with some algebra, Newton's second law, is we have force times time equals change in momentum. Okay? That's the equation. In other words, impulse equals change in momentum. And I think I should actually say that's the definition of impulse, right? Definition of impulse is force times time. That's what that means, okay? So, Let's see. Yeah, so we got a few equations here. Um, this right here is kind of the key when we study certain types of equations, or certain types of situations involving collisions, I should say. Okay, so let's look at a quick example just to kind of practice using some of these notions. Oh, oops. Okay, so here's an example. Actually, I'm going to pause this video and then I'm going to make another video where we do the examples. Okay, so this is already getting a little long, I think. I'm going to take a quick break, get some coffee, and I'll be right back with some examples. All right.